Here, correlation is also means co means two, mutual, right? Two, and relation, you know, relation, right? So first thing, the correlation is only between two variables, whereas regression is a relationship of one variable with more than one variables. It can also be one variable, one-to-one regression, and more than one variables like x2, x3 at the same time, xk. So one variable can be explained by more than one. But in correlation, we are specified to only one-to-one relation. So that's why it is defined as a coefficient of correlation, which is also known as a rho of x and y, which is given. So it means there is another thing which describes defined as the relation, which is covariance, right? So this is the formula. I'm not gonna get into the proof because it is like beyond our like coverage at this level. But if you are interested in mathematics that much, come to me later on and or ask me any question regarding this. I can send you the proof. So what is this? Can I say this one? What is this? This is covariance, right? So it is covariance of x and y divided by the combination of standard deviation of x and y. That's a covariance. That's a correlation. So it's specifically between two variables. Standard deviation of x times standard deviation of y. We know this is the root of variation, and that we have to calculate through this. So if we have a series of x, first we do x minus x bar, and if we have a series of y, these are two different series, y minus y bar, and do the summation, which then we have a multiplication x minus x bar times y minus y bar, and then you can find the correlation between these two word numbers. That's a coefficient of correlation, that how much the x series is correlated with y series overall, right? Not only one single data point, but a set of data points. So correlation provides simple measure of association. If we define, just like defining the regression, that between one and more variable, it's a simple association or link. Simple measure of association, let's say it in this way. Measure of association between two series. So that's the correlation. The degree of linear association between these two series, here, remember, it can be linear, right? Both the series are considered in correlation. We describe the equal. So xy, coefficient of correlation of x and y is equal to coefficient of correlation of y and x. So it means it's symmetrical. So this relationship is symmetrical. It's two-way. It only shows that change in one, let's say x. So change in one, let's say x, cause change in other. So until now we are same as we are defining the regression. Let's say y. But here it doesn't tell how much change. How much change in x brings how much change in y. This it doesn't tell. So that's the main difference between regression and correlation. Regression also tells us that how much change in X brings how much change in Y, so that we can make a good analysis. But in correlation, we cannot conclude anything. We cannot infer anything. Just we're gonna infer a simple association between two variables. For example, let's take an example of friendship. Um, you two, like you and your friend. Now your friend calls you one day and say that let's go, let's have a dine out, and she asks you to go with her for dining out, and you will say okay, I can go. Then she calls again another day. She said okay, let's go watch a movie. You say okay, you go. So next time she calls and say how are you and how's your health, you say I'm good, I'm fine. Next day she calls you and talk about more things. So in this example, only your friend is contacting you, right? You are not contacting back to your friend. So it's a can be a one-way relation. So we cannot get the correlation out of it, because correlation is symmetrical information. So if you are calling equally, if your friend is calling you every day equally, you should also call. I'm just giving it that if calling is a measure of is a proxy for measuring the relationship, then if you're calling every day, your friend should also call you equally. Then we can say that they are correlated to each other. But in this case, only one is impacting the other. The other one is not impacting. So one is dependent and other is independent, right? So the other doesn't care if you call or not call, but you care. Means you don't care if your friend calls or not. There is no impact on you. But if he calls or doesn't call, it impacts her. That is regression. So do you understand this example? So that's really simple example I took to find out the difference between correlation and regression. Whereas on the other hand, in regression, two variables are treated differently. That is, one is dependent, as I told you in an example, and the other one is independent. So X here is independent and Y is dependent, right? So Y variable is any random variable. So we can say it's any random variable. Random, what is random variable? Random variable which has some probability distribution. We have learned this before. That's why I told you all this. I explained you all those previous topics. So Y is a random variable. It means that it has some probability distribution, and X is assumed to be fixed. So X doesn't care, but Y cares, right? So X is fixed. That's the same. Consider the same example in the back of your mind, and then understand this. It will be clear for you. So Y is changing based on how X defines Y, but X is totally fixed or non-stochastic variable with repeated samples. Like X can only like get the calls at different times. Like you can only get the calls from your friends in different time, and it's okay, it's fine, it doesn't matter you. But your friend changes her behavior according to her your response to her in the call. So she is dependent on you. Same thing, you can take an example of you between you and your parents. But I think like friendship and calling is like a better example. So if your friend doesn't call you and it impacts you, then we say that it's a two-way regression, and there is a causality. Means the one is causing other, and at the same time other is also causing other one. So that's a causality. We will talk causal, and we measure it through Granger causality test. We're gonna talk more about this in later on in later lectures. But right now you understand, right? Do you understand? Do you understand the relation between? Okay, good, fine. So now you understand the difference between correlation and regression, the main difference. So which one is more powerful? If I want to define a relationship, which way, which measure is more powerful? Correlation or regression? Which one is more powerful, regression or correlation? For example, if I need to, I don't know, if I need to find out the relationship between you and your friend, shall I find out regression or correlation? Just type which one I should follow. Which one gives me powerful, stronger results to interpret, to evaluate your relationship? Correlation or regression? No answer, no reply so far. Oh, yeah, I got one reply. Let's see. Of course, regression, that's right. Um, because in regression, I can evaluate and I can make a judgment that is she your good friend or not. Just as an example, I'm just taking an example. Like I hope that uh, it's understood that friends always sit together, right? So if your friend sits with you, it has an impact on you, means that that's regression, right? So let's go forward quickly. So we know that regression is more powerful than correlation. We will talk more in details in next lecture. Coming to the so here we're gonna erase the regression, the correlation. So we will only talk about regression. And so first thing is simple regression. As from the name, it's understood. We're not gonna go in detail because we know that one variable y can be defined by many variables, can be explained by many variables, but in order to make understand it, we just consider simple. We just say that y is only explained by only one variable, and that's x. Only one variable. That's simple regression. It's easy to understand and do because we only say y depends on x. We restrict the real life scenario, right, in like one, because in real life one variable can be explained by many variables. For example, if the stock price is not only being explained by dividends, but it can also be explained by returns and many other stuffs, the expansion of the company, many other. But just to understand, we make it simple regression and we don't consider it other. In single, it can also be realistic because we just consider that if one variable, how highly is the other. So this regression, how high the changes of x. For example, x1, x2, xk have different impact on y, but we say that x1 has 90% impact on y, whereas x2 and xt maybe have 1%, 0.5%, and so on, so on. And total is like 100%. So we can say it's dependent on one variable. So mainly it's a simple relation of y. What are the examples? Can you give me the examples? So one example in financial world, from the financial world, is return versus risk. Right? Risk defines returns and return defines risk. That's a both way, by the way. Returns on assets. We're talking about assets and risk on assets. Then another is like stock prices, as I gave it this example many times, and dividends. And on EView, we're gonna talk about stock prices and returns. Just for an example. And third thing is hedge ratio. Now, what is hedge? You know return, you know risk, you know stock prices, you know dividend. Dividend is a profit which is given to a stakeholder based on the profit of a company, a portion of a profit. And stockholders are also stakeholders, so everybody gets the dividend. What is hedge ratio? Do you know about hedge ratio? What is hedge? So hedge means to protect anything you put against your loss, means to protect yourself from a loss, financial loss. That's hedging. Um, so hedge ratio is a ratio of a value of future contracts traded, because buying and selling is really important in hedging. So it's a value of future contracts by exactly the hedge. What do you hedge? Like the cash, cash, anything cash or cash commodity, you hedge. You plea. So that's a hedge ratio. So these two relationship between the value of future contracts and the value of a cash you are hedging, you can also find out a relationship, simple regression on that you can run. Now, first thing, when we have a series of x and y, first thing in regression, you can also see the regression by your eyeball. So there are values like 1, 2, 3, and 4, 5, 6 examples, so many values. So first thing, you can make a dot plot, or you can say scattered graph. So here on one side you have x, on the other hand you have y, and you have different relation. So I draw the values, the series of x and y here. It's obvious. I can see the relationship. The relationship is going like this, right? So it can give me a positive relation. And similarly, I can have another relation. And that's x and that's y if the data points are like this. So this is the negative relation. So first thing, I can get the regression relation by defining it on the scattered graph. Now, what do I do? Because now I'm moving to estimate this model, this relation, which I'm saying that y is dependent on x in simple regression. I'm estimating this. So I'm modeling this equation, this hypothesis that this variable is dependent on x variable. So first thing I'm going to take the observation, I'm going to take the data, and I'm going to throw it on the plot. And after that, I will see if it's positive linear or negative linear relationship, depends on the outcome. So if it shows if x increases, y increases. If it shows if x decreases, y decreases. But how much decreases, we don't know. So that's what we're gonna estimate. So what we're gonna put with our eye, we're gonna just fit a linear line. So some points are here on the line, but many points are not on the line here. And similarly here. So I'm just gonna take this one example, and you can repeat the same concept here on the negative terms, and you will understand. In Panama. Okay, so let's go forward. So here I can have two things I can retrieve. I can retrieve at every point here, from here to this point. There is a difference, right? From here to this point, and on this point, from here to this point, from here to this, from here to this, here to this. So there are different. We have to see that how much deviation of one point with the linear line. That's what we have to estimate. And that's the disturbance basically. In this case, we can say it is almost a straight line because there are some data points which are away, not in accordance. And this is not actual, but this is an eye-fitted line, but usually it's not that accurate, but just to give you like a basic concept. Now we have to measure exact slope. Now we have the line, so we have to measure the slope and intercept. And for that, we have this equation, linear equation. We have y equal alpha plus beta x. This is our linear relation. So first we need to find out alpha and beta because alpha is the intercept. What is intercept exactly? I will tell you in a while. And this is beta. How do we interpret? Beta is the slope. We call them, I'm gonna erase this one so that it can work here. So we call them parameters of our line, regression line. Parameter, you can also call it coefficient. Coefficients of x and y. So as you see the line, the main points are away from the line. The actual points are away from our estimated, our so far estimated line. So what is this? This is disturbance. So we can say that we have our regression line alpha plus beta x, but we can also have some disturbance, which means error. And we define disturbance is with the mu. So this is a slope, and mu is a disturbance from the main line. Disturbance means if you are standing in a line, I push you away from the line, and so I disturbed your position, right? Now your position is different. We can have this equation, and what are these things? With different observations, we have different values. For example, if y is a series, x is a series, so we can have every point have different disturbance. So can we write this yt equal alpha plus beta xt plus mu t, whereas t is equal to 1, 2, so many, n, right? So because there are so many points now, so every point we have disturbance. Understand? So you need to calculate these mu2 as well. We need to estimate this. One thing here is more than the line, more than the explanatory variable. So this is our explanatory line. On line we have explanatory function, which is y equal to f of x. So this is real points. This is expected points. So we define it with y hat. We can measure these errors, mu, disturbances, through two different things. One is method of moments, and the other is method of likelihood, which we're gonna cover in later on section, but for time being, it's not that important. So but the common method to estimate this line, exactly this line, and to find out the parameters, this one, mu, is very common method is to fit this line in OLS. So let's go to the OLS. OLS means ordinary least square method in linear regression. So can I erase this? I think I have to erase this because I don't have a bigger whiteboard. And I'm going to make a diagram here in a small way. So this one, just like one point is here, one point is. So right now it's an eye-fitted line. It's not an actual fitted line. So what I'm going to do, I'm going to estimate this through regression, OLS, through OLS method, ordinary least square method, and to fit exactly this regression line statistically. So we need to estimate here because we know that y equal to alpha plus beta x plus mu. So we need to estimate first, because this is given, we don't have these things, so we need to estimate alpha and beta to get the disturbance. So once we get the disturbance, we can say that this is exactly actual line should be fitted here. We need to minimize. We cannot minimize the error disturbance, because some disturbance is positive and some disturbance are negative, so overall it can come close to 0. So what do? We minimize the square. We minimize the sum of square residual. What exactly is this? Let's take one point here. So this is our line. Let's take one point. This is actual point. This is estimated point. So it is y hat t, and this point is yt. This is xt, and this is y. So this is the disturbance mu. Exactly, there is another disturbance mu. So if we add this, it goes to close to 0 already, or maybe it's 0. We cannot minimize 0, right? So what we do, we take a square, the square of this error, this disturbance, and we can minimize the sum of square residual. Got it? So let's move ahead in order to find out alpha and beta. It's a bit mathematically, but let's see. So we can say residual, what is the mu? What is the disturbance? So this is estimated one. Y hat is estimated one, right? So what is the disturbance? Exactly. Can I write this? Y equal to y hat plus mu. So this is our line, this is y hat, and these are the sum of the square of the residual. This is mu error. So this is mu series, so it is equal to actual y. So y series is given, actual series is given, that's what we have to estimate, and plus this. Can I write this? So can I say that mu equal to y minus y hat? Yes, I can say. So what is the mu square? Is equal, sum of mu square is sum of y minus y hat square. Can I write that? So I need to minimize this. I need to minimize this equation. This stuff. So let's go back to minimize it. So let's say this is A is y minus y hat square summation, because we need to find out this alpha and beta. So I just put it back, the value y minus alpha plus beta x, right? Okay, because we know y hat is this one, huh? Yeah, that's right. So if we put minus here, so it will also give me minus. So that's the equation. Now what I have to do the partial differentiation. You already know that how to do that. So first with alpha, then with beta. So with alpha, I get open like 2 here, sum of y minus alpha minus beta x, and then minus alpha means minus 2. So if I put summation inside, it can give me minus 2 sum of y. So sum of y minus NA minus, because its summation goes to constant, it gives me x. This. So first order condition, we put it equal to 0. So minus 2 will be gone because it goes there with 0. So this is one equation. Similarly with beta, I can get 2 summation y minus alpha minus beta x, and then derivation of with beta, so it's minus x. So again, it will equal to 0. So minus 2 will go there, and it will go as a change into 0. So I can have summation y minus alpha summation x and y. Yeah, summation x, because this x is here, because this is a variable, so I cannot make it 0, but that is constant. That's why I put it as a 0. So y minus alpha minus beta x equal to 0. And if I solve this one, I can get sum of xy minus sum of minus alpha sum of x minus beta sum of x k equal to 0. Now put the value of alpha here. We can get alpha from here, right? So if we solve this one, we can get na is on that side, so a is sum of y upon n minus b sum of x upon n, which means alpha is y bar minus beta x bar. That's alpha from this equation. So we put this there, right here. So we can get sum of xy minus alpha y bar minus beta x bar sum of x beta sum of x here. Just make it simplify it, and you will find out because this alpha we already put the value, so just solve it. So sum of minus sum of x into y bar. Can I write upon n into n? Yes, I can write this one minus plus beta x bar into sum of x upon n into n, yeah, minus beta sum of x here. So you will get here. Let me write it in simple way. So I can write in simple way sum of xy minus n bar and x bar y bar plus beta x bar square, because this is also x bar, into n minus beta sum of x square. So this is equation I get equal to 0. Now if I solve this one, let me remove this one because I already know the alpha here. So if I solve this one, I can get beta equal to n x bar y bar minus sum of xy upon n x bar square minus sum of x square. So now I have series x and y given. I can get x bar, I can get y bar, I can get sum of xy, I can get x bar square, I can get sum of. So this is the proof, but you don't need to do it proof again and again. You just need to know this formula. We can also write it in this way: beta equal to sum of xy minus n x bar y bar upon n x bar square minus sum of sum of x square minus n x bar square. So you just need to know this formula. I just told you so that you understood how it works. Yeah. And once you get this beta value, put in this beta value in here, and you can get alpha as well. So that's how we do. We get the intercept and slope. Now we know the intercept and slope, put it in an equation, and we can get the value. So just hold for a second, I will be back. So now you got how to get the linear equation. So that's a simple regression model. So what is the reason behind the error? We already learned, because when there is like a certain point, so every point is different than the fitted line, right? So there can be one reason, because there can be more than one variable, more than x1, there can be x2, x3. So that's also can push this estimation. There's another reason, is that the error in y, because we need to estimate y and x as well. So there can be error in both y and also x. So error in y may not be observable. So we don't know what is the error. We learn this disturbance mu, we learn in error in one, but we cannot observe error in another. So in OLS, sometimes it's really not the accurate measure to get the regression relationship. So we go forward, we go next, because there can be a problem of consistency. What is this? There can be a problem of heteroscedasticity. There can be problem of multicollinearity. That maybe there is a relation between error terms of x and error terms of y, which we are not observing. So if we don't observe that one, it means our results are not unbiased; they are biased. So once we got these distances, we measure this distance, then we know that how we need, because we need to concentrate this distance to get to our line. So after running OLS, the equation must be more like this. So now the error term is minimized. Before we have like this. So here the disturbance is higher. After running regression, we are close to our y hat. Not exactly there, but close. So do you understand? So now if you have any x and any y, you can get beta and alpha, and we call it also estimators. So estimators are the one who can measure the exact relationship. How we define it? Let's say we have after running a regression OLS, we get y hat equal to -2 plus 0.5 x. Now we know that we have a series of x and y. Oops, it's not working. Why is not working? Let's do it like this. X and y, right? So we have series. Now we have y hat, which is this. So we can calculate y hat -2 plus 0.5 and putting the value of x here, and we can have another series of y hat, right? That we can get. Now how do we interpret alpha? Alpha means if there is no change, still y has changed. Still y will decrease by 2 units. if everything is in units. So now that's the interpretation of intercept. It means there are other variables, there are other factors which are influencing y. That's why we need to run this regression. And what does slope means? This is alpha, this is beta, right? Remember. So beta means if there is 1 unit increase in x, y will increase by 0.5 units. Remember, every data is in units. So that's how we explain. Now, before the times end, let me take you to because we will cover in next lesson. So before the times end, let's talk on the EViews. Also, for that, I'm gonna share the screen. Now, this is important. All of you brought the computer, right? Yes or no? Did you bring your laptop, your computers? No? Some of you did, right? I saw it. So, is it too boring that someone is sleeping? Okay. So wake up call. Wake up call in last 10 minutes. So don't sleep, right? Just 10 more minutes. We can run the EView. So now you're gonna share the screen. I'm gonna share the screen. And we're gonna run EViews, okay? So yeah, you see, board is sometimes whiteboard is not helping out. It makes you sleepy. I already took an example. Remember last time we collected the data on H&M? So I'm just putting it in on EViews. So let's see if EViews open it or not. There are different ways we can do it. You also need to know this one. Okay, cancel out. So what you're gonna do, you're gonna go file. Remember, file, new. Remember these steps, file, new, work file. So here I'm gonna use monthly data. So the year which I'm gonna start, I'm gonna use this file. So this data is H&M stock price and H&M returns, right? So year is gonna start 2014 and month is October until 2020 and month is August. Okay. Now file, new, import file, and just need to go to desktop, Econometrics, classes, EViews example, time series 1. Yes, this is the series. Let's go. Let's go. So start date is 2014, 010. Yeah, that's the data. You see the date change. Finish. No. So now we have a series. So these are the two series. I'm gonna open is as a group. You can see now this is the stock price, the first one, and the second one is the return. Just view, get a common sample, and get the mean. You can get the mean. mean, median, maximum, minimum. So first thing you need to present it. So you see the probability of the data. So mostly it's like stationary data, but the second series is not stationary. So you need to make it stationary. That how we gonna do that? We can see. So here we can have sum and sum of square deviation. So total observation is 71. So we have n71. Now next thing we're gonna view it as process. So you processes and make, there are different ways. You processes and make an equation. So this is equation. So I want to see that how the stock prices have an impact on returns. So there is a constant. Constant means alpha, intercept. So this C is intercept, and I'm just running simple OLS, which is least square in this. So you see there are different kind of regressions you need to know, and we will learn some of them, not all of them, which are most importantly in financial set. So this is least square. So you see the data is from 2014 October to 2020 August. So just do this. There are some options which you're gonna, so it's a covariance method is ordinary, none, none, and then just simply specify. That's how you specify our equation. So actually, this is our y, the return, and this is our x, the prices. So how the stock prices influences the returns, let's see. Just a random example. See here, we have this equation. So it's gonna do with this equation. Yes. So here we don't need to conclude. So what this it means? Where is the regression result? Where? Oops. Process, make equation. Okay. So here, best way is to select it and copy it. Now dependent variable is returned. So what does this equation means? So this is our alpha and this is our beta. So our alpha says that if there is nothing happened in the stock prices, the return will decrease by 3%, because here it's like in units. So there is a decrease of a 3% in the return if there is nothing happen, if the stock price is the same. So shall I invest in this stock? No, I shouldn't. Same thing happens. It says that if the stock price is increased by 0.02%, by 1%, so the return will increase by 0.00123 by 0.02%. So that's how we interpret. So we need to see the R square. R square is the correlation, right, between these two. So this relation between this return and this stock price is very low, very low. It's like 1%. So which is not, it means that this model is not correctly specified. We will also see that what are these other tests and what does how does they interpret. So here probability of F statistic is giving us the probability of overall model. So overall our model means these two variables are not that much influenced, and overall model is also insignificant. So our model is wrong here. So we need to specify the model. We need to find out different other variables, right, which are missing variables. So that's how we run EViews. You can save it, work file, save, and then you can save it in EViews. Okay. So that's how we define. So hope you have understood the lesson. Wait. We still have 4 minutes. So where everybody's going? I think the class finishes at 10, right? Isn't it? Isn't the class finishes at 10?